Hi. In this new episode, we're going to discuss the information design approach to alternatively restate the context of Bayesian persuasion. So basically, information design and Bayesian persuasion, they are talking about the same problem of this strategic information transmission problem where the sender can commit to the signal and then the receiver receives the signal and then takes the action. So basically, information design approach or this way of expressing the Bayesian persuasion problem, it could perhaps bring us some convenience to study this problem, and later we will show that actually by formulating this problem within this information design context, we can allow us to actually to formulate this problem within the incomplete information game framework. Okay, and that is pretty similar to the mechanism design approach, right? So which is simply another perspective to see this problem. Okay, so now let's take a look at this approach and see how we're doing this. So basically, we will go through the papers from Bergemann and Morris from in 2016 and 2019. There are two papers for this information design approach for the Bayesian persuasion problem. Okay, so first we define a basic game. So this G, it has some ingredients, and this AI is the finite set of the actions by player I. So accordingly, this player I is just an element in this set of the players. So AI is the action set, and the UI, of course, this is the payoff, this utility function. So this omega is, again, it's the state space, and we have a mu naught for the prior belief of this omega. And this mu naught is an element of the interior of the delta omega. Okay, so here we can actually have multiple players, but such as the example we mentioned before, the sender or the prosecutor, that information designer or the person who is making this information structure is not included in the set of the players here. Okay, so we mean that the multiple players here, it could be multiple receivers. Okay, so but here remember that in our last example, there's only one receiver, which is just the judge, right? So here we have not only one player in this game, but actually this framework allows multiple players in this game. So we can see that the action A here, the set of all the actions, which is just the product of all the actions from all the players, right? Okay, all right, so now we have those definitions and notations, and then okay, so those are quite similar to what we have defined in the standard Bayesian persuasion approach, right? So let's review our example. As I just mentioned, we have only one player, which is the judge in this set of the players, but the other settings are quite similar, right? So the action could be acquit or convict, and the space and then the state space is binary. Either this guy is guilty or innocent. So the prior and for the big G or big I are the same, exactly the same as before, and the utility function for this judge is the same. If a good person is acquit, then the judge has utility of 1, or a bad person is convicted. So both leads to the utility of 1 for the judge. But if the state of this person and the action, those things, they don't match, then it's 0 utility for this judge. Okay, so those are pretty similar settings in the example as before, right? So we define our outcome, okay, V, which is an element of the set of distributions of the product of the state space and the action space. Okay, so and now we can define this information structure within this context. So which is capital T. It has two ingredients. So here Si. Okay, so this is just a finite set of the private signal realizations of player I themselves. Okay, so we can see some sort of the piece of useful thing for us to maybe to guess that this framework could be later used as a game with multiple private signals, right? Okay, so Si is the set of finite set of the private signal realizations of player I, and pi is the is just the signal itself, right? So S is just then the product of all the S's. So this pi, okay, so this is the new definition, the new way to define this signal structure, right? Or information structure. So this pi here is an element of the set of all distributions over the product of the state space and the signal realizations, right? So intuitively, remember that we have mentioned this before in the beginning of the Bayesian persuasion that the signal structure could be defined in two ways, right? So one way is the standard way that we use the conditional probability to define those signals, right? Or signal structures. But here, alternatively, we can use this joint probability rather than the conditional probability to define this pi, right? Okay, so and remember that when we mentioned this way, the alternative way to define this pi is such that the marginal probability of the pi over all the s's is the common prior mu naught. Okay, so that's why we have this following equation here. So it means that if we sum this pi, the joint distribution over the s and omega, so if we sum over all the s's, right, so it means that there's no randomness for this s, and the only random variable left is this omega. Then of course that the probability of this omega from the ex ante perspective, then this is mu naught, right? So that's part of this definition for this new way to define the information structure, right? And now let's go back to our old example. Okay, so in the old way, we have our the S set includes G and I, of course, right? In the old way that we use this pi prime to denote the old way of definition of this signal, right? So we have those numbers for the conditional probabilities of given the state of this person is guilty or innocent, then this sending some signal which is little g or little I with those probabilities, right? So remember those numbers. But here, in the new way of defining this information structure, then we have this T, which has two things, S and pi, right? So S is the same as this, but pi here, okay? So this pi now is the joint distribution that we defined here, right? So this pi actually here, so for example, pi of little g and big G, so then this is simply calculated from the conditional probability times the prior, right? Which we have this result here. And similarly, we can get all those pi's for the different combinations of the state and the signal realizations. And of course, those results or those joint probabilities, they exhaust all the possibilities for this for this combination of the S and pi, right? Right. So okay, now we can say that this T, okay, so this T, the information structure, and G, the basic game, so they together consist of an incomplete information game, right? And formally, this G, including all the actions, utilities, and the state space and mu naught prior. So the T includes all the SIs and the pi. So as the information structure. So G and T together defines this incomplete information game. So later we'll use the corresponding some other solution concept to solve this game and try to explore some useful properties based on this information design approach to study the Bayesian persuasion problem. Okay.